Hey, all. So today we're talking about the mind-brain identity theory, which, if you think about physicalism, just the rough idea that mental states are dependent on physical states, um, it's it could easily be the sort of view that comes to mind, and a bit inaccurate, but at least somewhat illuminating kind of motto for it is just that the mind is the brain. Um, so. Um, So remember that every mental state is dependent on on a physical state, according to physicalism. And um, the way that we cash out this idea of dependence, well, it can come in a few different ways. And You'll remember that Ryle defined mental states in terms of behavioral states, right? Um, and it's a little bit different for Smart. He doesn't define um, mental states in terms of brain states. And we'll see what the difference is between, but he does nevertheless identify mental states with brain states. And we'll see what the difference is. It's a subtle difference, but it's an important one. And it does a lot of work in helping Smart respond to objections to his view. So the general overview that we'll do is we'll kind of get his view out at exactly what it means. And then we will look at some objections, just as he does. I'll follow him closely. And then at the end, we'll look at an alternative to the mind-brain identity theory, a form of dualism, different than Descartes. But basically, Smart's main consideration in favor of mind-brain identity theory will come out at that point. And plus, you'll learn a couple new things about dualism. So, oh, you know what? Let me go ahead and, so you're not distracted by the following slide, change the size of my screen a bit. Okay, so so very roughly, like I said, according to mind-brain identity theory, mind is identical to the brain. Your mind is identical to your brain, or mental states are identical to physical states, but that's very rough. So the first thing we have to do is we have to distinguish between two ways in which we can identify mental states with brain states. And this rides on the type token distinction. So just to give you an idea of what I mean when I say the type token distinction, ask yourself, how many words are in this box? Now, if you're anything like me, part of you is going to want to say 5, and another part of you is going to want to say 2, right? And the reason that you have these kind of conflicting urges to answer this question in different ways is because there are 2 word types in the box, but 5 word tokens. A token of a type is like an instance of that type. And a type is, at least one of the more straightforward ways of understanding it, is it's like a kind of an abstract entity. And tokens can have similarity to one another kind of in virtue of being the same type, right? So that's the basic distinction between type and token. And it's really easy to kind of grasp that distinction kind of when you're talking about linguistic items like words. But it can happen in kind of other realms too. So there's a type of thing, an elephant, right? And well, let me just use an example that I have at hand. There's a type of thing, dog, right? And Dan is a token of that type, right? I'm not a token of that type. I'm a token of a different type, a human, right? So it needn't be thought to be relegated to the realm of language. There's kind of a general distinction between types and tokens, and each object we run across is a token of that type. What's the type of this? Well, a phone, right? And this is a specific token of it. And tokens, at least, can be kind of spatiotemporally located physical entities, right? And the word tokens in this box are all located in space, right? This token of tiger is to the left of these other two tokens of tiger, right? So they have different spatial locations relative to one another, right? They're just words written on a page or sounds uttered into the air, right? But types are going to be more abstract, right? The type of the word tiger is not going to really be located anywhere in any clear sense. One way you can say that it has a location is to say that it's kind of located everywhere where its tokens are. Similarly for dogs, right? You can think of the type of dog as kind of an abstract entity. And if you want, you can say, you know, it's located wherever its instances are, wherever its tokens are. But you don't have to. You can think of it as an abstract object that exists outside of space and time as well. You know, what you do is just a whole other debate about the nature of types, and we won't worry about that. The important thing is that you understand the distinction between a type and a token, and that they're not the same thing. Whatever a type is, whatever its nature is, it's different than a token, right? So the mind-brain identity theory can be cashed out in two ways. One is in a way that identifies types of each type of mental state with a certain type of brain state. And the other way to cash it out is to understand it as a claim about tokens only and not types. So on this view, every token mental state, so every kind of every instance of being thirsty that I have, right? I have one right now, but it's different than the one that I had yesterday at this time. You know, this is typically the time I get thirsty, let's say. They're different tokens of a mental state. One happened yesterday, one's happening right now, right? So on this view, you know, each of those tokens is identical to a brain state, but it makes no claims about the identity between the types of, you know, the being thirsty mental state and the, you know, whatever brain state, you know, you might consider, whatever sort of brain state you might consider identifying with. It doesn't say that type of being thirsty and type of, you know, neurological event sort A, that they're identical. It's just saying, look, every time you have a token of a being thirsty mental state, it's going to be identical to a particular brain state. What sort, that's not really important. The view doesn't say anything about that. The type view does, however. So just to get a better grip on the distinction between type and token identity theories, this distinction, well, an example of a type identity theory is one that comes from philosophy of science. So it's standard in the philosophy of science, or not standard, but there's a big, heavy discussion in the philosophy of science about whether you can reduce certain physical properties to other sorts of physical properties. So before the mid 19th century, we kind of had this notion of temperature, which was relatively well defined, right? We had mercury thermometers by then, and we were able to measure the temperature of certain items with a relatively good degree of accuracy, maybe not up to today's standards, but we could do it. So we had this kind of physical notion of temperature in our pockets. And then at one point, we kind of came up with the atomic theory of matter, and we started realizing that, matter was made out of these small particles, and each of these particles has a certain energy, and they kind of vibrate or they move around, right? And at some point, somebody said, well, look, maybe temperature is just mean kinetic energy of molecules, of the constituent molecules of the object whose temperature you're interested in, right? And this sort of claim is a type claim. It's a type identity claim, where you say, look, just the whole type or property of temperature is just mean molecular kinetic energy. Contrast this with a fake theory, but it at least hopefully gives an idea of the distinction between the type and the token. So it would be crazy for me to advocate a type theory of emperor penguinhood and Antarcticanness, right? So let's suppose for a moment the emperor penguins are the only animals indigenous to Antarctica. I think that's right, but I could be wrong, or at least like the only large animals, right? So it would be crazy to say that to be an Antarctican is just to be an emperor penguin. Because when you make a type identity claim, you're making a really strong claim. You're making a claim about the types. And so you're basically ruling out that you could have an Antarctican, a native Antarctican, that's not an emperor penguin. But this seems possible, right? It may not have happened on Earth, but we can imagine like a geological and evolutionary history on Earth where, you know, other things besides emperor penguins were native to Antarctica. But a token version of the identity theory is a weaker claim. And it's true at our world, right? So this says that every emperor penguin is the very same thing as, that's what I mean by numerically identical, as some animal that is native to Antarctica, right? And that's true. And notice you're not making any claims that, you know, every animal you find in Antarctica has to be an emperor penguin here. You're just saying that for any emperor penguin that you find, right, it's going to be, in less stilted language, it's going to be native to Antarctica, right? And you're not saying anything about, you know, you're not saying the reverse holds, that everything you find in Antarctica, every animal is going to be an emperor penguin. Moreover, you're not making an identification between the types of things. You're not saying to be an, well, let me put it a little bit different. You're not saying that, that the types are the same sort of thing, right? So imagine the property of being an emperor penguin, right? You're not saying that that's the very same property as being an Antarctican. And think back to the rhenate chordate case. This can be helpful. When you're so a rhenate's something that has kidneys, a chordate's something that has a heart. It turns out that, you know, every rhenate is a chordate in our world and vice versa. And so kind of a token identity theory is true in both directions of renates and chordates. But, you know, we don't want to identify those two types of things because they involve different organs, right? Renatehood involves mention of kidneys and chordatehood involves, you know, hearts. And so, you know, they're different types of things, renates and chordates, even if it just so happens to be the case that in our world, you know, all renates are chordates and vice versa, right? Similarly, emperor penguinhood seems to have something to do with, you know, your internal biology or your DNA or something like that. Whereas Antarcticanness seems to have to do with certain facts external to you, like about where your ancestors kind of evolved, right? And so they seem to be different types of things. So you don't want to make that stronger claim, right? Now, these theorists who are trying to identify temperature as a type with mean molecular kinetic energy, they want to make the strong claim because they're not just saying that every time you run across something that has a temperature, that temperature is going to be the same thing as its mean molecular kinetic energy. They're saying something stronger, that that, you know, temperature just is mean molecular kinetic energy. And you're never going to find something that has a temperature and doesn't have, you know, a mean molecular kinetic energy or vice versa, right? So like I hinted at, the idea of type identity theory in science often is the result of what's called intertheoretic reduction, where you try to reduce, you know, certain theoretical terms, certain scientific theoretical terms to others, what you might take to be more basic. Or more well-defined terms. So, you know, our old theory of temperature employs terms and predicates like heat, cold, is hot, is cold. And the new theory employs terms and predicates like mean kinetic energy of constituent molecules, is high, is low, right? And so you can think about the reduction as happening where like kind of mean kinetic energy of constituent molecules kind of gives rise to heat, right? And in a way that, and they're the same thing, really. But there's a certain asymmetry, right? Where you're kind of explaining the more commonly well-known phenomenon in terms of kind of the scientifically more rigorous phenomenon, the scientifically better defined phenomenon. And in doing this, you kind of simplify your kind of scientific worldview, right? Because before the theoretic reduction takes place, you have to have two things hanging around. You have to have temperatures, and you have to have energy of molecules, right? But when you say that temperature is nothing other than energy of constituent molecules, then you only have one thing lying around, right? You just have that one thing that is both heat and mean kinetic energy of constituent molecules. And mean kinetic energy of constituent molecules is really just the same sort of thing as any sort of energy, right? The energy that I have, right? And the energy that larger objects have too. So you've kind of reduced your ontology, the set of things you take to exist, by employing this intertheoretic reduction, and that's one of the advantages. And we'll see that it's connected to Smart's main argument for identity theory. And he wants to do something different. He's engaged in intertheoretic reduction, where he takes the terms from a certain theory, which is our theory of folk psychology, which is kind of a pre-scientific or non-scientific theory that has predicates like believes, desires, is pleased, is in pain, and so on, and gives explanations based, using those sorts of terms. And what Smart would like to do is say, no, that those sorts of things that you're talking about, pleasure, pain, desire, belief, each of those things is identical to just a certain neurological state. And so, he's kind of reducing his ontology. He doesn't need to have beliefs, desires, pleasures, and pains hanging around in addition to neural state A and neural state B and neural state C and so on. All he needs is one thing, and it happens to be both neural state A and desires, right? So I've jumped ahead a little bit, but the idea is that you're reducing heat to mean kinetic energy of constituent molecules, and for something to be hot is just for it to have a high level of energy of its constituent molecules, right? So when I say the sun is hot, I'm just saying, or when for the sun to be hot is just for its constituent molecules to be very high, right? So just like with theories, theories involving intertheoretic reduction in general, you can have kind of a type version, or you're going to have a type version. There's going to be a weaker token version too, but Smart is advocating the type version. He's saying that every type of mental state, desire, or perhaps desire for a particular thing, is going to be identical to a certain brain state. And he's not saying just that, anytime you find someone with a desire, perhaps for a particular thing, it's numerically identical to some token brain state, but it doesn't, but without any claim as to, the identity between the types of those things. Every type claim is going to entail a token claim. So if you think that every desire, if you think that the type of mental state desire is identical to the type of brain state B, then you're going to hold the thesis that for any token desire that you pick out, it's going to be a brain state of the sort B, right? But the reverse doesn't hold, right? You can hold the token theory without having to hold the type theory. So the token version is always a weaker version of the view than a type version. And as I explained, intertheoretic reductions typically presuppose a type identity theory rather than a token. And the reason I mention this distinction between type identity theories and token identity theories is not just to give you a better idea of type identity theories by contrasting them with the alternative, but it's also to note, to kind of prime you for later views about the nature of the mind that we'll talk about, that are token versions of the mind-brain identity theory. So as far as Smart goes, he's going to, as I said, adopt a type identity theory. And so he's going to say, like, pain is the same type of thing as parieto-insular cortical neuron firing. So these are the sorts of neurons in our brain that are responsible for pain. Their firing is what, is what we think is manifested as pain. And there's a causal chain that you can identify between them. And on the one hand, between certain sorts of pain-inducing environmental stimuli, and on the other hand, certain sorts of behaviors that we typically associate with someone being in pain, like wincing and so on and so forth. But notice the big difference, and this is a good point to say this, between Smart's picture and Ryle's picture. He thought of the individual as a black box where you put the inputs in and you get the behavioral outputs out. And he identified the the mind with the behaviors, right? But Smart's saying, no, I'm not going to imagine the individual as a black box. I'm really going to kind of get inside their brain. And I'm not afraid to go in looking and see how their brain works and see how it connects up causally to these environmental stimuli and the behaviors on the output side. If you're a token person, then all you're committed to is saying that every token pain is numerically identical to some parieto-insular cortical neuron firing, but you're not making any type identity claim between pain as such and parieto-insular cortical neuron firings. You're just saying, well, it just happens that, you know, each token of pain is identical to some parieto-insular cortical neuron firing of that sort, or some neuron firing of the sort parieto-insular cortical, you know. So the picture of intertheoretic reduction at play in Smart's picture is going to be, look, we're going to kind of reduce pain to parieto-insular cortical neuron firings by identifying the former with the latter. Pain is kind of a less well-defined concept, and we're going to kind of replace talk about pain, officially anyway, with talk about parieto-insular cortical neuron firings. And so when you say something's in pain, like say Bob is in pain, for Bob to be in pain is just for some of his parieto-insular cortical neurons to be firing, right? There's no difference between his pain experience and that. So I've said all these things before, but just to reiterate, intertheoretic reduction yields a type-type identity theory, and we can take Smart to be advocating a type-type identity theory, as he's interested in kind of the theoretical reduction from folk psychology that explains actions in terms of mental states, using terms like pain and desire and believe. Reducing that talk to reducing those properties of pain and so on to properties that are better defined scientifically, right? Like parieto-insular cortical neuron firings. And, you know, he doesn't say that we have a complete picture, nor does he think that we have to have a complete picture, neuroscientific picture, and know everything about how the brain works in order to push this view. So a really important and subtle distinction, or an important and subtle point to keep in mind, is that for a type-type identity theory doesn't imply synonymy between the two sorts of terms. And I've tried to be careful, as I was talking before, not to kind of suggest that it does, although I've had to catch myself a couple of times because it's really easy to do. So when you do an intertheoretic reduction of, say, heat to mean molecular kinetic energy, you're not saying that the term heat and the term mean kinetic energy of constituent molecules mean the same thing. Even though you're saying the property of heat just is the property of mean kinetic energy of constituent molecules, right? The type of thing heat is just the same as the type of thing mean kinetic energy of constituent molecules. And why not? How can you say that the types are identical without saying that heat and mean kinetic energy of constituent molecules mean the same thing? So here's kind of a way to illustrate it. Imagine yourself living in the 1700s or 1600s or 1400s or 400 AD. Someone who lived then certainly understood what it means to say that the pan is hot, right? They had an understanding of heat and temperature, right? But they had no clue about what mean molecular kinetic energy is, right? They might not even realize that pans have constituent molecules, right? If we go back far enough, right, before Dalton, we didn't have a scientific atomic theory of matter, and it was talked about by some ancient Greeks, Democritus and Leucippus. So take yourself maybe even before them, right? So you just kind of maybe imagine the world as just kind of one big whole, right? One thing, only one thing exists, right? What we think are parts, excuse me, what we think are parts aren't really parts. They're just kind of like, they're just like modes of the world was a fun way to put it at a certain point. Properties of the world. Now, you can have this, so you can be completely unaware that the world is made up of these, small atoms, right? And so they might not know anything about that. They might not know anything about energy. I mean, energy is a relatively recently defined concept as well, only since, the 1800s as well. But it seems like this person can grasp the meaning of the pan is hot without understanding anything about, molecules and so on. And so when you make a type identity claim, what you're saying is not that heat and, kinetic energy of molecules mean the same thing. You're saying that, you're saying something a bit weaker than that, which is that the property heat or the type heat is the same thing as the type having high mean molecular kinetic energy. And maybe an example will help. I don't have this example in here, but I think it'll be helpful, so I'm just going to talk through it. So think about the planet Venus, right? That's what we call it now. Now, way back in the day, say in the Babylonian times, they had, well, this is the Greek version, but Greek has these words Hesperus and Phosphorus, right? And Hesperus means the evening star, and Phosphorus means the morning star. And because Venus's orbit is inside the Earth's, Venus, you never see Venus very far away from the sun in the night or morning sky. Either it's on the same side of the sun as the Earth is rotating toward, in which case it pops up in the morning just before the sun, or it's behind the sun, in which case you don't see it, or it's in front of the sun, in which case you don't see it, or it's behind the sun from the perspective of the rotation of the Earth. And so, when the sun sets, so let's say the sun's up here now, and the sun's setting, my thumb, imagine yourself on my thumb. As the sun sets, the last thing you're going to see, say Venus is right here, is Venus, right? But it's never going to be too far from the sun. You're never going to see Venus like in the dead of night at any time, because it's so close to the sun always from our perspective, because its orbit is inside the Earth's. So there was a time at which astronomers weren't sure that these objects, the ones they were seeing in the morning just before the sun during parts of the year, and the object that they were seeing just after the sun set at other parts of the year, were the same object. They were both very bright. Many people probably had a hunch, but there was probably a time where we were completely agnostic about whether those things were the same thing. And so we gave them, different names, Hesperus and Phosphorus, right? And so someone can, so say there you have so way back in those days, imagine you have someone who is a late riser, and they never are up at sunrise. And so they've seen the evening star, right? And well, I mean, we don't even have to imagine someone like that, right? Just imagine someone who yeah. So imagine, just to forget about the late riser bit, just imagine somebody back then, right? They can understand the meaning of one of those terms, the evening star, and not the other, the morning star. Yeah, okay, maybe suppose that they're a late riser. Maybe they've never seen it, they've never been introduced to the term the morning star. They wouldn't know what anybody was talking about if someone said it to them, because they've never encountered people talking about it before. They can understand what it means to be Hesperus, right? they understand what better way to put it is they understand what Hesperus means. It means the evening star, right? It means the star that you see in the evening just after the sun sets at certain parts of the year. Now they might not have no clue about the existence of the morning star, Phosphorus, because like I said, they're never up in the morning. And so they don't need, but note that Hesperus and Phosphorus refer to the same object, right? And so despite the fact that Hesperus, the term, and Phosphorus mean different things, right? Because one can grasp the meaning of one without even ever having run across the other term, like our late riser. This can be the case even though they refer to the same object. And what's going on in the case of type identity theories is they're doing something similar. But rather than saying that, you know, these two names mean different things despite that they pick out the same object, we're now talking at the level of properties rather than objects. And, you know, an object is something like, you know, this particular phone or Donald Trump or Venus. And a property is something like, you know, greenness or hot or being in pain, right? These are the sorts of things that objects can have, but don't stand alone, right? They kind of have to have objects to have them in order for, you know, them to be present in the world in any sense. So, so properties for the type identity theorists are kind of, they're the analog of the object in the Hesperus and Phosphorus case. And term like heat and terms like mean kinetic energy of constituent molecules, those are like Hesperus and Phosphorus, right? Where just because those phrases kind of pick out the same property, according to the type identity theorists, it doesn't mean that they mean the same thing. And that's why someone can understand what it means for a pan to be hot without also understanding what it means to say the pan's constituent molecules have a very high energy, right? So what I said just about heat and kinetic MMKE, mean molecular kinetic energy, can be said of pain and parieto-insular cortical neuron firings. They can fail to mean the same thing, even though, according to SMART, they're type identical. And similarly, we can imagine someone, you know, pre-neuroscience, perfectly well understanding what it means to be in pain. I mean, they've had their fair share, and despite not knowing anything about neuroscience, right? So anyway, so hopefully the Hesperus and Phosphorus case will give you at least some sort of something to grip on in order to kind of understand this kind of subtle point that just because two properties are the same doesn't mean that, you know, words we use to express those properties have the same meanings always. Now there's some kind of like, so just to shift gears for a little bit, there's some general considerations in favor of mind-brain identity theory. And the first one is more general, and the other one that I'll talk about right now is kind of a more specific, you know, a more well-developed version of the first one. But the first one just kind of gestures at some sort of at least general dependence between our mental states and our brain, right? And, you know, just a very crude example, right? If you take the brain out of someone's body, they're going to stop reporting that they have pleasure, pain, etc., or reporting at all for that matter, right? Whereas that's not the case with other parts of our body, right? If you remove my hand, I can still report, you know, for example, being in pain, which most likely I will report if you cut my hand off. Now, another, you know, a way to kind of flesh this out a little bit more was so back in like the mid 20th century, when experimental ethics, you know, ethics involving scientific experiments wasn't as, you know, well developed as it is today, people could kind of get away with a little bit more. And so there were scientists who would do things like, you know, and under certain circumstances, I'm sure this still occurs, but they would cut, you know, a piece of the skull off, and then they would apply electrical impulses to certain parts of the surface of the brain. Um, and you know, and what would happen is that people would report sensations that they weren't receiving any environmental stimuli for through their senses. And these sorts of experiments, I don't know, you know, what specific sorts of hypotheses that these scientists were trying to confirm, but one general, like, philosophical hypothesis, anyway, that that kind of gets confirmed by the kind of total body of these sorts of experiments is that um, is that changes in the brain, in the kind of distribution of electrical potentials in the brain, can um, result in reports of individuals that are the same sort that they would give if, you know, they had environmental stimuli of certain sorts, right? So, you know, suppose the scientists, you know, add some electrical charge here, and the subject reports seeing blue, right? Um, so this would be the sort of report we'd expect if we put a big blue piece of paper in front of them. But we get it, we can get it without having to do that. We can just, you know, apply a certain voltage or whatever to right here, and, you know, with the head cut open, and we get that report as well. So it seems like our experiences are somehow very tightly connected to our brain. And that at least starts people wondering, well, maybe, you know, the brain just is the mind, right? Now, before I talk about Smart's kind of official argument for his view, and it's really very simple, uh, but he kind of, before he does it, he forestalls a number of objections, and many of those objections have to do with a confusion, or ultimately his replies to them ultimately make use of this confusion between, you know, just assuming that terms like mind and brain have to mean the same thing, even though, you know, because they refer to the same thing. So the first one's just maybe the best example of that, and how this distinction, an example of this distinction best being employed in reply. So, so the first objection is roughly just that someone can know about sensations, but not about neurophysiology. And I don't want to spend much time on this because we've already talked about why Smart thinks this is the case. It's not because, you know, mental states are distinct from physical states, like, you know, Descartes thought, for example. Instead, it's because, you look, when I make a claim about the identity of two types of things, like, you know, pain and parieto-insular cortical neuron firings, I'm not saying that pain and parieto-insular cortical neuron firings, those expressions mean the same thing, right? And so that's what explains why someone can know about sensations, but not about neurophysiology. Just like our Babylonian friend can know, our Babylonian late riser can know the meaning of Hesperus, right? But not phosphorus, even though they refer to the very same object, even though the objects that they refer to are identical. They are one and the same thing. The second one is kind of a point that it's just the point that, look, Smart, you're saying that pain is parieto-insular cortical neuron firings, but we could be wrong about that. Maybe our, you know, it will require more work and thought to uncover what, you know, pain truly is. And ultimately, Smart's going to say, that's fine. You know, I might give a few examples just to put some, you know, put some meat on the bones of my view, and say, for example, that pain is parieto-insular cortical neuron firings. But I'm not married to that identity. Basically, what Smart wants to say is, what pain is whatever brain state neuroscientists tell us it is. And so that's really the all he wants to push, right? The third objection is a little more involved. So certain qualities of sensations are different from qualities of brain states. So let me say a little bit more. being a yellow-orange flash is the example that he talked about. Imagine, you know, there's a light bulb up here and it goes off, right? And I'm bathed in a yellow-orange flash, right? So I've just turned my lamp off. There it's on and turns off. I have this experience of a yellow-orange flash, right? And you know, my experience can be described as, oh, that was a yellow-orange flash, right? And just imagine the brain state that I entered when that flash happened, right? Call it brain state C. That's not a yellow-orange flash. If it was any color, it was probably the gray of brain matter, right? But it certainly wasn't a yellow-orange flash. It's not like when when a yellow-orange flash occurs near you and you are looking at it with open eyes, then like that, then there's something yellow-orange that pops into your brain, right? That's not what's going on, right? So this, at least on the face of it, seems to be a bit of a problem, right? And Smart's reply, first of all, he distinguishes between sensations and experiences. And he says that it's kind of a mistake to think about there being a sensation of a yellow-orange flash in your mind. Or at least it's a mistake to think that Smart's saying anything about sensations. What he is saying something about are experiences. Kind of, if you took sensations to exist, an experience would be kind of a larger process that would involve a certain sensation, but it would also involve you, the observer, right? Perhaps, and you know, so you can understand it more as a process rather than kind of a little picture in your head, right? And so what Smart wants to focus on is the experience. And he says that there's a way to understand the claim that this experience is a yellow-orange flash in a way that's consistent with his view that that mental states are identical to brain states. That each type of mental state is identical to a certain type of brain state. So he says that this experience as a yellow-orange flash should be understood as, this experience is what it is like what is going on when I have my eyes open, am awake, and there is an orange illuminated in good light in front of me, right? And so we can thereby compare other experiences that we have, like this one with the lamp that I have this yellow-orange bulb in, because, you know, it's like the experience that I have when I'm in good light, sitting there looking at an orange, right? And so that's how he thinks we can make sense of this kind of this talk where we attribute properties to experiences that don't seem to be attributable to him. He's saying, well, you need to kind of understand that in the right sort of way. We're not literally saying that there's something yellow-orange in my head. What I'm doing is I'm comparing this experience implicitly to other experiences that I've had, right? And, you know, it will be more similar to certain experiences that I've had than other experiences, right? The experience that I had when this light flickered was more similar to my experience this morning, right before I started cutting up my orange to eat for breakfast. It's more similar to that experience that I was having then than it is to this experience that I'm having now looking at this phone, right? Right. This light and an orange look much more like one another than that light and this phone, right? So being a yellow-orange flash for Smart is really just being something that is like what's going on when I have my eyes open, am awake, and there's an orange illuminated in good light in front of me. And that's a property that a brain state can have, right? There's no question about that we can make these comparisons between brain states. That's not problematic. So onto the fourth objection, sensations are not in space, sorry, but brain states are. So here the objector is trying to kind of appeal to the indiscernibility of identicals. If X and Y are the very same thing, then they have to have the same properties, right? So if a sensation is a brain state, well, then you shouldn't be able to find any properties that one has but the other doesn't, right? And the objector here is finding one, namely, well, sensations don't seem to have a spatial location, but brain states do. When the lamp flashed, there was a particular location in my brain that was activated, right? Or maybe several locations scattered across my brain. But anyway, it was a well-defined region of my brain where there was activity going on, and there was not activity in other parts of my brain. But where was my sensation that I had when the light flickered? Well, it didn't feel like it was anywhere different than certain other sensations I have. All the sensations I have feel like if they're anywhere, they're in the exact same place. Just think about what it feels like to have a certain sensation. Do they feel located anywhere? Well, no. Other than in kind of this general region here, if anywhere, there's still going to be a discrepancy between sensations and brain states. And there's a little bit of like presupposing dualism, or at least some, some dualist predilections here, because of course, Descartes' thinking of the mind as kind of an unextended sort of point-like thing, and sensations are going to be in that thing, in some sense, in a non-spatial one, presumably. And so, they're not going to have any location, just like the mind technically doesn't have any location. So how does Smart respond to this problem? So his basic way of dealing with this problem is just to say, well, look, it's an ignoratio elenchi, which is to say, it's a straw man. It's you're setting me up. You're saying you're setting up an argument against a claim that that I didn't make, right? And so this is on page 150 to 151, where he basically says that he's not arguing that an after image is a brain process, but that the experience of having an after image is a brain process. So it's kind of connected to what I said in the response to 3. We need to make sure that we're talking about experiences and not brain states, right? And in the end, he ultimately kind of bites the bullet against this corrected version of the objection, because he says, according to me, experiences are going to be locatable in space. The experience of seeing the flash of the lamp, whatever sections of my brain light up, that experience is going to be there and not in the sections that didn't light up. And now when I have another sort of experience, like an auditory experience rather than a visual experience, of say Dan snoring, right? Then different parts of my brain light up, and that experience is somewhere else, right? It's in a different place than my experience of the lamp was. And so he's, in a way, he's just kind of owning this objection, at least the corrected version of it, when it's clear that we're talking about experiences and not sensations. And then the 5th objection is kind of similar to the 4th, in that the objector is kind of looking for a property that a brain process can have, but experiences don't. And this is now the objector has been corrected and is talking about experiences, not sensations. And basically, you can think of the idea is that you can think of brain processes as being swift and slow. So maybe there are certain portions of your brain where the neural connections are packed more tightly than in other parts of your brain, and so certain brain processes that involve those pathways of higher conductivity occur more quickly, whereas those that occur in pathways of lower conductivity occur more slowly. But it doesn't seem like certain experiences that you have occur more quickly or more slowly than others, given a certain time interval. So say that flash takes 1 second to happen in my experience of it, right? And then someone, I don't know, pops an orange through the doorway for a second and pulls it back, right? Those two experiences don't seem to, it's not like one of those experiences seems to happen more quickly than the other. Well, we're both talking a duration of 1 second, and so that's supposed to be fixed, but then yeah, it doesn't seem like one happens at a different speed than another. So this, this doesn't, this isn't particularly um, uh, satisfying. So in the end, Smart kind of bites the bullet here as well. So he says on page, let me just find it because it's a nice little quote. He says in the end, it's kind of a bit concessive, but he says, all I'm saying is that experience and brain process may in fact refer to the same thing. And if so, we may easily adopt a convention, which is not a change in our present rules for the use of experience words, but an addition to them, whereby it would make sense to talk of an experience in terms of appropriate physical processes. And so what he's basically saying here is that once kind of neuroscience is developed, and if its language were to kind of be adopted by the folk more generally, it would start to become, and the more, people in general are aware of the vocabulary of neuroscientists and stuff, and the better they learn it and so on, it's going to start sounding less weird to say that the sorts of experiences that involve those high conductivity pathways are swifter than the ones that involve the lower conductivity pathways. So he's basically saying, while it sounds weird to our ear to say that an experience happens quickly or slowly, it's only because we're steeped in the language of folk psychology, talk of experiences, beliefs, desires, pain, pleasure, and so on. We're steeped in the talk of experiences and not in the talk of neuroscience. But if that were to change, right, then we would become more copacetic to these sorts of phrasings. So the sixth one, again, another kind of stab at the mind-brain identity theory due to alleged properties that differ, sensations being private, brain processes being public. And the idea is that there's kind of an important difference, because suppose that, because a scientist looking at my brain could be having an illusion and mistake what's going on in my brain with pain, when in fact it's pleasure, right? They're just tired or whatever, and they mistake this combination of activity shown on the MRI with pain, when it's in fact pleasure in this particular instance. So what's going on in the brain is kind of a public matter. We can be right or wrong. Others can be right or wrong about it, but sensations are private, and the individual doesn't seem able to be right or wrong about it, right? If I'm feeling pleasure, then I know I'm feeling pleasure. And if I'm feeling pain, I know I'm feeling pain. And so there's kind of a difference between these two things. Now, his response is connected up to the idea that words for experiences like pain don't mean the same thing as words for brain states. So it's connected up to that issue. But again, he kind of appeals to the idea that if neuroscientific vocabulary is kind of, first of all, developed by the neuroscientists and then adopted more widely, it might be less weird to be able to say, it might be less weird to say that Smith is because by looking at an MRI, right, it might be less weird to say, Smith is having pleasure and pain right now because he's in this brain state, right? Because we're at this stage, or at least we were back in when Smart wrote this paper, which is mid-20th century, because we're at this stage where we don't kind of have that sort of MRI-based information available to us all the time, really the only person who's ever in a public setting able to say anything authoritative about their brain states I'm sorry, about their experiences is the individual having them. But if we all had like little screens that showed an MRI just attached to our heads and we walked around with them all the time, then we would be able to start correlating, you know, the activity on those images with the environmental inputs and behavioral outputs of people. And so we can start to get an idea about what each of those images kind of represents as far as an experience goes. And so you can think about, like, if we were really good at this because we had a lot of practice, we always wore these things, and so we always were observing everybody's brain states as they interacted with their environment. We could probably like tell stories to one another, fictional stories, non-fictional stories, based on just a flickering series of images of several brains, right? So you have a couple of brains, and you know, just by watching the pictures of the brains flicker and the activity change locations in the brain, someone who's practiced in this art would be able to say, oh, this person just angered the other person because this person is having anger signals at the moment, and this person is having contrition signals at the moment. They're feeling sorry, right? And or guilty or something along those lines. And so so the idea is just that the kind of language, the kind of resources aren't in place for us to be able to say a lot of things about the mental states, or sorry, about the mental states of others from a purely physical perspective. But that's not to say that in principle they couldn't be, right? And this concern is related to the eighth concern as well, which I'll go ahead and talk about now, just because it's so well connected. So the concern with objection 8 is that descriptions of experiences are private. They can't get a foothold in language, since any rule of language must have public criteria for its application. And Smart's concern is that, or Smart's reply is that the objection, if it's sound, is really just an objection to something like Cartesian dualism, Descartes' dualism, where introspective reports are genuine in that they're reports of kind of sui generis mental states or characteristics. Sui generis just meaning a sort of its own, right? Rather than being reducible to another type of thing like brain states. So it is no objection to a weaker thesis that I would be concerned to uphold, namely that if introspective reports are experiences or genuine reports, then the things they're reports of are in fact brain processes. And think back to this weird world where we all wear MRI readouts on our heads, and we have these little portable MRI scanners that are constantly scanning our brain. If this was the linguistic environment that we grew up in, we would have public criteria to be able to confirm people's mental states outside of their behaviors, right? And it would be kind of directly related to their neural states rather than their behaviors. And so this is why Smart doesn't think it's a problem for his view. In principle, at least, there's a sort of science fiction-y sort of situation that we can imagine where we are able to have public criteria for someone, you know, being in a certain mental state via our public criteria for being able to know that they're in a certain brain state. It's the Cartesian who says that mental states are distinct from brain states that doesn't have, even in principle, a way for another person to get access to those and confirm that they have them. Remember the problem of other minds? That's just what this is right here, right? It's rearing its head again, right? And so for the final objection that Smart talks about, it's conceivable that I turn to stone yet retain the ability to have sensations. He basically replies to this by saying that that experience, he basically pulls out the whole, you know, type identity theory doesn't involve sameness of meaning claim. He says, look, this is on 152. I can imagine that the electrical theory of lightning is false, that lightning is some sort of purely optical phenomenon, having nothing to do with electricity. I can imagine that lightning is not an electrical discharge. I can imagine that the evening star is not the morning star. So just imagine a solar system in which, you know, there were two stars that were responsible for the observations of the ancient Babylonians. There were two celestial objects. Let's not call them stars because they might not be, because in fact they're not. It's a planet. Um, but it is, right? But the evening star is the morning star. But lightning is an electrical discharge. So the mere fact that we can imagine um, uh, lightning as not being an electrical discharge and the evening star as not being the morning star doesn't mean that lightning is not in fact an electrical discharge and that the evening star is not in fact the morning star. So similarly here, you can imagine yourself um, having a certain physical substrate and yet still having aches, pains, and so on. But that doesn't mean that 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 uh, that aches, pains, and so on are just identical to certain brain states that we have. So it's the gap in meaning that allows us to conceive of these certain possibilities, and it doesn't require a gap in reference to to objects or properties to allow for the conceivability of those possibilities. So in the end, that's a lot of objections that SMART considers. Um, the most important thing to keep in mind, though, because this is the easiest thing for people to forget and thus to misunderstand SMART's view, is that that point that's come up in SMART's reply to several objections, which is to say that to identify the type of, say, desire with the type of brain state B, or the type of pain, the type pain with the type parieto-insular cortical neuron firings, that's not to say that those terms, pain and parieto-insular cortical neuron firings, mean the same thing. Okay, so SMART's argument is really simple. It's just, look, my ontology, that is the class of things that I take to exist, is more parsimonious than dualism. And he talks about this view called epiphenomenalism, which is, on his view, the most plausible form of dualism. And we'll talk more about epiphenomenalism toward the end of our discussion of the nature of mind. But I do want to introduce it now just so you kind of know what he's talking about. So epiphenomenalism differs from Cartesian dualism in a couple of important ways. So Cartesian dualism is what we can call mind-body-substance dualism, the view that minds exist and bodies exist, and these entities are all distinct from, all the minds are distinct from the bodies, and vice versa. And they're independent of one another ontologically, in that either can exist without the other. Descartes would think if God wanted to, he could just create the minds and no external world. But he didn't want to. Maybe it's in the nature of his all goodness that he gives us things to do. And so he wanted to give us experiences. And the only way he could do that in a non-deceptive way is to actually create a world that corresponded to the experiences that we were having. Now, there's a distinction between substances and properties. You can think about a substance as a type of, as an entity, right? A thing that has properties, right? It's a thing that can be a certain way. Atoms, human bodies, chairs, rivers, planets, minds, and so on would all be substances. Properties is just a way that something can be. Like being 5 kilograms in mass would be an example of a property, or having your parieto-insular cortical neurons firing, that would be an example of one. And being in pain would be an example of a property as well. And what substance dualist says is that there's two types of substance: physical substance, atoms, humans, bodies, chairs, and so on, and mental substances, minds, and that they exist independently from one another. Each could exist without the other. Property dualism, on the other hand, is that you have just one type of entity, but you have these two different types of properties. You have physical properties, like being 5 kilograms in mass, or having your parieto-insular cortical neurons fire. And then there are mental properties as well, like being in pain. And the idea is that for the property dualist, the difference between them and SMART is that you can't reduce the property of being in pain to the property of having your parieto-insular cortical neurons firing. They have to be two distinct properties. Another component of Descartes' view is that it's interactive substance dualism, that substance dualism is true, and then minds can cause changes in the body and vice versa, right? Minds can cause changes in the external world through the exercise of the will, and then ultimately the control of the motor neurons and so on and so forth. And then the external world can cause changes in minds, right? A big anvil falls on me and I'm in pain, right? So just imagine a mental event to be, now what epiphenomenalism is it's a version of property dualism. So imagine what's going on in versions of property dualism is you have these mental events that you have, oh, I'm sorry. So I skipped ahead a little bit. So there are two ways to think about mental events versus physical events, depending on whether you're a substance dualist or a property dualist. If you're a substance dualist, you can think of a mental event as a change in a property of a mental substance, a mind, and a physical event as a change in a property of a physical substance, right? A human body, a planet, a star, and so on. So the picture on interactive dualism is going to look something like this. Suppose I stub my toe, and then my parieto-insular cortical neurons fire. I feel pain. I therefore form the intention to curse. Like, I'm going to curse right now. It'll feel good. And then I curse, right? The picture according to interactive substance dualism is something like this. You have the mental realm on top that houses all the mental entities and mental events. And then you have the physical realm on bottom, which houses all the physical entities and physical events. And then there's like causal arrows that cross back and forth over, right? And so A here is my stubbing my toe, which causes my parieto-insular cortical neurons to fire. And this is a change that happens just in the physical world, wholly within the physical world. But then this, according to Descartes and other interactive substance dualists, causes a change in my mind. I start being, I'm in pain. This causes me to form an intention to curse, and then I exercise my will, I control my motor neurons, and then I actually curse, and I bring things back into the physical world, right? So you can think of the process as running something like that, right? Start at T0, then this happens, stubbing toe, parieto-insular cortical neurons fire, I'm in pain, I form the intention to curse, and I curse at T5. And there are problems for interactive dualism, right? Mental objects don't seem able to transmit physical quantities, so it's not clear how they could cause physical events. And even if they could transmit physical quantities, you would think there would be violations of conservation laws governing those physical quantities. So once my parieto-insular cortical neurons cause me to be in pain, they would have to kind of lose some energy to do that. And then some energy would disappear from the physical realm, but there's a conservation law of energy that says, look, energy has to be conserved in the physical realm. That's usually just understood. And then later on, when, if I died right before I formed the intention to curse, then that energy would never be put back into the system. And so you'd have violations of that conservation law. Epiphenomenalism is interesting because it kind of takes as part of its motivation this problem for dualism, that mental objects can't transmit physical quantities. Although it doesn't do an excellent job of dealing with problem 2. But the idea is that it's a version of property dualism, right? So I'm just repeating slides here just to remind you of what they are, just so they're handy as you scroll through them. And you think about mental events and physical events in a little bit different a way on property dualist views. You say that a mental event is a change in a mental property of a substance rather than a change in a property of a mental substance. And a physical event is a change in a physical property of a substance. So really, here we can say, so according to epiphenomenalism, physical events can cause mental events. And mental events can cause mental events. But mental events have no physical effects. So thereby you kind of deal with the problem that how would a mental entity transmit a physical quantity, right? You don't have to deal with that anymore. What's going on according to epiphenomenalism is that these mental changes are kind of like a byproduct of physical changes. So let's just look up the picture of how this goes. A, I stub my toe. B, my parieto-insular cortical neurons fire. Then I'm in pain. Then I intend to curse. Then I curse. And let's add a new one in here. F, my being in a brain state responsible for me intending to curse. Because if you remember on the previous slides, I didn't have like a physical substrate for my intention. So let's add that in just to make the picture better, the picture more complete. So according to epiphenomenalism, I'm still dividing like mental events from physical events, but it's not because they're different types of substances. It's because C and D are events that are the result of a change in mental properties, where A, B, F, and E are just changes in physical properties. But the idea is that you have this kind of causal line from my stubbing the toe, then my parieto-cortical insular neurons fire, and that causes in me to go into a different brain state, which is responsible for my intention to curse. And then finally, that causes me to curse. Now, according to the epiphenomenalist, C and D, my actual feeling pain and my actual forming the intention to curse, are not really involved directly in the causal chain as causes. They're merely side effects of certain brain states that I've entered, right? C, that is my pain, being a side effect of having entered a state where my parieto-insular cortical neurons are firing, and D, my forming the intention to curse, being the result of me entering a different brain state after that, right? So the picture is going to look like this. I stub my toe. That causes me to go into, it causes my parieto-insular cortical neurons to fire. That causes me to be in pain, but it's not my pain that then causes me to go into another brain state. It's the parieto-insular cortical neuron firings that do that. And that brain state causes me to form the intention to curse. And then it's not my intending to curse that causes me to curse. It's that brain state that's responsible for me forming my intention to curse that causes me to curse. So really, all the real action is happening on the physical level, right? And what's going on in at the mental level are just these kind of side effects of what's going on at the physical level. And so at each step, we kind of have something that we have a physical cause, right? So there's never any question about mental events imparting physical quantities. We don't have to worry about that issue. You might still be worried about problem 2, but even that can be dealt with a bit, because remember that we're not assuming 2 different types of substance. We're just assuming 2 different types of properties. So it's really only one substance that's involved in all these changes. And so it might be that the laws of conservation aren't violated like they would be according to substance dualism. At this point, when B imparts a certain physical quantity to C, it's not as if that energy leaves, the physical realm. It can be in the physical realm as long as all substances are physical substances. It's just that they can have both physical and mental properties. So the epiphenomenalist has a good way to respond to problem 1 for interactive dualism, and it has maybe a semi-plausible way to respond to problem 2, in virtue of the fact that it's not a form of substance dualism. Smart's argument is like, look, epiphenomenalism, he just assumes. He doesn't go through the stuff that I just went through, but he just assumes, because people had written on this stuff before, that epiphenomenalism, if you're going to be a dualist, is the way to go. It's at least the most scientifically respectable form of dualism. And he says, look, okay, fine. Let's say it's the most scientifically respectable form of dualism. My view, my mind-brain identity theory, still has an advantage, because I just have fewer things to posit than the epiphenomenalist. I have, I just need to posit events. Let me go back. A, B, F, and E, and the epiphenomenalist needs to posit all that plus C and D. So there's a picture of, here's a picture of Smart's view, which is just B and C become identified. My parieto-insular cortical neuron firings become identified with my pain, and my my intention becomes identified with another brain state. So really, I only have 4 things hanging around, whereas the epiphenomenalist has 6 things hanging around, right? So the picture on the physicalist side of things works like this. And at certain points in the paper, uh, Smart complains about these nomological danglers. And what he has in mind are these things, C and D. They're danglers, right? Because they don't really do anything. They're just these weird little side effects of physical processes. And Smart's just saying, we don't even need these physical processes. I mean, already on the epiphenomenalist picture, all the events that matter, that is, all the events that we can kind of like observe, are already fully explained by the physical events that came before them. And so these epiphenomenal danglers are just, these nomological danglers are just completely unnecessary elements to be added into what we take to exist. And we might as well just get rid of them. Epiphenomenalism, epi in Greek means next to. And so the idea is that our phenomenal world kind of is runs parallel to the physical world, but kind of really doesn't have any interaction with it. It doesn't do anything to the physical world. And that's why it's called epiphenomenalism. So anyway, Smart's argument for his identity view, relatively simple. Let me get back to where I was. But there are still a couple of problems remaining. And we'll talk about these more. But the first one is called the multiple realizability of the mental. And yeah, so some of the readings we'll talk about will focus just on this issue. In fact, the next one will on Putnam. The problem is, like, look, if pain, for example, is just for my parieto-insular cortical neurons to fire, then if there are animals that don't have parieto-insular cortical neurons, then they can't be in pain. And suppose that all animals on Earth do have parieto-insular cortical neurons, although I think they don't. I think that some don't, but let's just suppose they do. Well, it's perfectly reasonable that there could have developed aliens with a different sort of evolutionary history on a different planet that don't have parieto-insular cortical neurons. They have a very different physiology than we do. And yet, when they're subjected to certain environmental stimuli, like having something thrown at them, they behave in the same sort of way that we do. And so these sorts of considerations suggest that they can be in pain, but according to the identity theorist, because they don't have parieto-insular cortical neurons, they can't be. And one thing about identity, identifying types of mental states with types of physical states, using identity as the relationship to them, between them, is a strong claim, right? If I know that Sam Clemens is identical to Mark Twain, and I know that, but I know that I don't know, Walt Whitman is not Mark Twain, then I know that Walt Whitman is not Sam Clemens, right? Because this is just the way that identity works, right? It's if you know that A equals B, A is identical to B, it's the very same thing as B, and you know that B is the very same thing and you know that B is a different thing than C, then you know that C also has to be a different thing than A, right? And that being the case, if you know that pain is just parieto-insular cortical neuron firing, and you know these aliens don't have parieto-insular cortical neuron firings, they have something else, then you know that they're not in pain because you've, at least as the mind-brain identity theorist, you've identified pain with parieto-insular cortical neuron firings. You've identified pain with a certain sort of physical structure that these aliens don't have. And yet the aliens, we're supposing, still have behaviors that suggest that they can be in pain, right? So because they're animals that don't have parieto-insular cortical neurons, you can use them as your example, right? And just think about how they would respond to, stressful environmental inputs. We might imagine that they respond how we do. We want to say they're in pain for that reason, but the mind-brain identity theorist doesn't have that luxury because of how strictly they marry mental states with brain states. The second problem is qualia again. So you might not have been convinced by Smart's replies to some of those objections. And you might have said, it's just weird that you're saying, for example, that experiences can be fast or slow, or that they can have a spatial location. What I mean when I'm talking about experiences is something that doesn't have those things. Um, and think about what it's like to, you know, be thirsty or to eat an apple, right? And just, you know, just right now, if you've got something handy to eat, right, eat it right now. I don't, unfortunately. Um, but and while you're eating it, just kind of just close your eyes and just concentrate on the feeling that you get when you're doing so, the feelings that pop up, the taste, right, so on and so forth. You keep doing this, the more you think about it, the more skeptical you become that any sort of physical description of your brain can capture how it feels to you. And that's the qualia problem, right? The idea that no matter how much third personal physical description you give of the physical end of an experience that you're having, right? Like what's going on in your brain, what behaviors you're exhibiting, to tie this back to behaviorism, because remember, quality is a problem for behaviorism too. No matter what you do, if you appeal to both behaviors and neural states, you're never going to be able to kind of capture, it doesn't seem, that feeling that you get when you eat a crisp, cold apple, right? So it leaves us with the problem of qualia as well. The next paper that we'll read on Putnam, he engages directly with the problem of multiple realizability of the mental. But we're gonna leave the qualia problem till the end. I mean, we'll come back to it at various points through, but as far as like really engaging with it, I wanna talk about a few more versions of physicalism, because as we'll see, each of them has a real problem with qualia. So anyway, sorry, this one was a long one, but I will see some of you for Q&A.